As AI technology continues to become advanced, AI-powered tools are increasingly being used to support teaching and learning. These tools can provide instant feedback, generate learning materials, and help users to understand complex topics more easily. For this project, Gemini is selected because it is capable of handling a wide range of academic and non-academic tasks. It can also assist users from different educational backgrounds and support various learning needs. For provide context, we also look at Kamigo, which is an AI learning assistant developed by Khan Academy. Different from Gemini, Kamigo is specifically designed for educational purpose only. It focuses on guiding learners through problem solving and encouraging critical thinking rather than simply providing answers. In this evaluation, we will examine how Gemini performs under different prompting strategies and assess its effectiveness, strengths, and limitations in educational settings. Next, we will discuss the significance and impact of using Gemini in education. Starting with the advantages. Gemini improves accessibility to learning resources by providing information anytime and anywhere. It also allows learners to progress at their own pace, making learning more flexible and personalized. In addition, it helps to save time by quickly generating explanations, summaries, and learning materials. However, there are also some disadvantages. Since Gemini generates responses based on patterns in data, its answers is not always accurate. As a result, students may learn incorrect information if they accept responses without verification. Similarly, educators may unintentionally spread inaccurate knowledge if AI-generated content is not carefully reviewed. Over-reliance on AI tools may also weaken users' critical thinking and problem-solving skills. Next, looking at the stakeholders. The first group is students. Students interact directly with Gemini through conversational prompts and can receive personalized explanations tailored to their learning needs. However, they should be able to evaluate the information provided and compare it with reliable sources to ensure accuracy. And the second stakeholder group is educators. Educators can use Gemini to prepare learning materials, generate assessment questions, and explore different ways of presenting information to students. Despite these benefits, educators must also address challenges that related to academic integrity and assessment authenticity, as students may misuse AI-generated content in their coursework. Next, we are going to discuss the educational workflow of Gemini, showing how users interact with the system to obtain information and learning support. The process begins with question identification. At this stage, a user encounters an academic challenge or requires additional information. The user first identifies the problem and determines what information is needed. And the next one is prompt creation. The user translates their question or problem into a prompt that Gemini can understand. The quality of the prompt is very important because it can directly influence the quality of the response generated by the AI. And the third stage is AI processing. Gemini analyzes the language used in the prompt, identifies the concept, and processes the information. Based on this analysis, it can predict the most appropriate response. And after processing, Gemini moves to response generation. The system generates a response, which may include explanations, examples, or solutions, depending on the user's request. And finally, the workflow ends with human review and verification. Users should evaluate and verify the information provided by Gemini using reliable sources and their own judgment. This step is very important because AI-generated response may sometimes contain inaccurate information. Next, we compare direct prompting and structured workflow prompting by using a table. Direct prompting is the simplest prompting method. The user submits a request directly without providing additional instructions. Its main advantage is that it is quick and saves time. However, the quality and depth of the response may vary depending on how the prompt is written. In contrast, structured workflow prompting provides clear instructions and organizes the task into defined stages. This helps the AI to generate more detailed and consistent responses. However, it requires more effort from the user because the workflow and instructions need to be planned beforehand. Although this prompting method requires additional effort, it is often preferred for educational tasks because it improves clarity and reduces the possibility of incomplete responses.
Next, I will present the section 3, which is the multi-dimensional AI evaluation framework. The purpose of this section was to evaluate the quality of Gemini's responses in educational contexts and compare two prompting approaches, namely direct prompting and structured workflow prompting. Instead of evaluating responses based only on whether they were correct or incorrect, we used 5 evaluation dimensions. The first dimension is fidelity, which measures the accuracy and correctness of the information provided. The second dimension is coherence, which evaluates whether the response is logically structured and easy to follow. The third dimension is relevance, which measures how well the response addresses the user's request. The fourth dimension is usability, which focuses on how understandable and useful the response is for the students. Finally, consistency evaluates whether Gemini produces stable and reliable outputs when responding to similar tasks. Each dimension was assessed using a 4-point scale ranging from poor to excellent, 1 being poor, 2 being fair, 3 being good, and 4 being excellent. To ensure a fairer comparison, we designed a controlled evaluation procedure. First, the same AI system, which was Gemini, was used throughout the experiment. Second, we selected 2 educational topics that are commonly encountered by artificial intelligence students. The first case study focused on machine learning using the concept of overfitting. The second case study focused on algorithms using bubble sort time complexity. For each topic, we created 2 versions of prompts. The direct prompting approach used a simple question. For example, for the overfitting topic, the prompt was simply as explain what overfitting is in machine learning. The structured workflow prompting approach provided Gemini with a sequence of instructions. For example, Gemini was asked to first define overfitting, then explain why it happens, and provide a real-world example, and finally explain one prevention method. To avoid biasness, every prompt was executed in a completely new Gemini chat section. This was important because Gemini can use previous conversation context to influence future responses. By using a new chat each time, we ensured that no prior information was carried over and that the response quality depended only on the prompt itself. After collecting the responses, we evaluated them using the 5-dimensional framework. This is the screenshot of the Gemini's responses to the direct prompting and structured workflow prompting for case 1. This is the screenshot of the Gemini's responses to the direct prompting and structured workflow prompting for case 2. After evaluating all responses, we calculated the scores for both prompting approaches. The results shows that both direct prompting and structured prompting achieved the maximum score for fidelity. This indicates that Gemini was able to provide factually accurate information in both case studies. However, the differences appeared in other dimensions. For coherence, structured workflow prompting received a score of 4, while direct prompting received a score of 3 that gave us the average of 3.5. This is because structured prompts guided Gemini to organize information according to a predefined sequence, making the response easier to follow. A similar pattern can be observed for relevance and usability. The structured prompts produced responses that focused directly on the requested information, whereas the direct prompts sometimes included additional explanation that were useful but not strictly necessary. Consistency also favored structured workflow prompting. Since the prompt clearly specified the response structure, Gemini produced outputs that were more predictable and stable. Overall, direct prompting achieved a total of 70 out of 20, while structured prompting achieved 20 out of 20. To conclude, our evaluation demonstrates that prompt design has a significant impact on the quality of AI-generated responses. Both prompting approaches were capable of generating accurate educational content, which is reflected in their high-fidelity scores. However, structured workflow prompting consistently outperformed direct prompting in terms of organization, relevance, usability, and consistency. This suggests that providing clear instruction and breaking tasks into smaller steps helps Gemini generate more focused and high quality educational responses. Therefore, for academic learning and educational support, structured workflow prompting is the recommended approach because it enables students to obtain responses that are clearer, more structured, and easier to understand.
Okay, thank you. So let's continue with the hallucination test. So there was three type of prompting that we use in this test, which is direct prompt, chain of thought prompt, and structured prompt. For the direct prompt, what we asked to Gemini is explain how generative AI works, and for the chain of thought prompt, explains step by step how generative AI works, and for the structured prompt, we divide it into three section, which is input, processing, and output. Explain how generative AI works using the following structure, which is for the first section, input. Describe what kind of data is given to the generative AI system and how is it represented. And for the second section, processing. Explain how the model learns from the data and how it processes input using its internal architecture. And for the third session, output, which is describe how the model generates final results based on the input and learn patterns. Keep the explanation simple, clear, and suitable for introductory AI course. So those are the prompt that we use for the hallucination test. So let's continue with the result of prompting. So for direct prompt, which is the hallucination type that we detect is hover hallucination risk with mild elaboration. Although the answer is correct, it has a tendency to be overly descriptive. Despite being accurate, the answer includes terms which are not within the range of this topic and thus poses the possibility of being overly elaborate. And for the chain of thought prompt, the hallucination type that we detect is hover specification hallucination. For the analysis, while the answer is correct and logical, it contains too many technical terms compared to what was needed in the question. It is an example of over specificity hallucination, which means adding more information than necessary for a simple explanation. And for structured prompt, the hallucination type that we detect is low hallucination risk. The answer is precise and well written while conforming to a correct structure. No errors, in fact, or hallucination are noticed, although the sophisticated technical information does not fit into introductory question. I think that's all for hallucination test. Alright, thank you. So let's continue with the retrieval augmented generation, which is RIG, and knowledge grounding analysis. So this is the list of documents used in this test. So we have 5 documents, and each topic is different. Which is the first document is introduction to machine learning for IoT. For the second document, introduction to generative AI. For the third document, deep learning, recurrent neural network. For the fourth document, computer vision convolutional neural network. And for the last document is computer vision feature extraction. Let's continue to the next. So this is the result of the test between RAG and without RAG. So for the first test case, MLIoT broad explanation with extra concept, and with RAG lecture aligned explanation of IoT intelligent transformation. For test case, generative AI includes RLHF, diffusion and transformer detail, but with RAG focus on tokenization, embeddings, data space and sampling. For the test case RNN, the result of without RAG include RSTM, GRU and vanishing gradient, while with RAG focus on hidden states and sequence processing. For the test case CNN, with the RAG, result is includes full architecture including fattening and softmax. With RAG, focus on convolution, pooling and dense layer. And the last test case, feature extraction, which is without RAG, it include SIFT, HOG and deep learning details. With RAG, focus on definition, rows and importance. And that's the result of the test, which is between RAG and knowledge grounding analysis. That's all from me. Let's continue to Laila. Thank you.
Now, my teammates showed Gemini can give accurate answers when prompted and grounded well. My question is even harder. Even when it's accurate, is it fair? A model trained on the internet inherits the internet's biases, and we found two. First, cultural bias. Gemini defaults to Western examples. When we asked for Malaysian references, it reshaped existing Western studies to look Malaysian instead of finding real local ones. Second, authority bias. It answers in the same confident tone whether it's right or wrong, and it pushed advanced concept at a beginner level with total certainty. For students, that confidence gets mistaken for correctness. The impact is false knowledge and over reliance. We can reduce it with better prompts, RAG, and cross verification, but never fully remove it. That's why human oversight matters. Gemini can catch its own bias and it can't be held responsible. A person can. Can AI be trusted in high stakes settings like medicine or law? Not unsupervised and not yet. The core risk is hallucination. Gemini is wrong in the same convincing voice it uses when right, so users can tell the difference, but it's not hopeless. Structured prompting and RAG both improved reliability in our tests. That means trust can be engineered through the system around the model. The right framing isn't AI versus humans, it's AI under human oversight. And the better AI gets, the more tempting it is to stop checking, which is exactly when oversight matters most. Therefore, every section pointed the same way. Structured prompting beat direct on coherence and consistency. RAG improved accuracy and traceability, and bias carries real risk in education. Across all of it, one theme held: human oversight is essential. Gemini is genuinely useful, but it has no real understanding of truth or fairness and can't be accountable for mistakes. So it works best as supervised collaborator. So students and teachers must stay critical, verify against trusted sources, and keep the final responsibility. That's all from us. Thank you.